Good day. I welcome you back on this journey with me. Welcome back and please join in to learn embedded system on ARM Cortex M4. Today is day 4. I hope you have revised day 1, 2 and 3 and you are more familiar with the ARM Cortex M4 series now. Okay, let's jump into the session to see what we have. Excuse me. Today we're going to see IDE. What is it and how to install the IDE. On learning, we're going to cover what is IDE and how IDE is going to work, and what is a linker and how it is important in the IDE, and go through the steps of installation of STM32Cube and also the 32Cube IDE options. Then we're going to chat about the debugging options in embedded code and some programming options. And this is a bit of a theoretical bit practical because we're going to install the IDE. I hope and believe this will be interesting for you. So please stay tuned and let's get in and learn. Once again, for your own practice, these are all the materials you need so you can have a better practice and understand more. The more you have hands-on and practice yourself, the better you can be and acquiring the job that you are all after. So these are all the materials that's required. Please contact Pantech Solutions and they would be happy to source you all this and provide you all the help that you are after. Okay, here we go. Are you excited to learn? That's good. So let's go. What is IDE? IDE stands for Integrated Development Environment. It is a combination of compiler, assembler, linker, and loader put together in under one roof, if you like, in under one environment. So everything has got its own functionality to do its job. So that's why the IDE is really good to have everything in. And what is a compiler? A compiler is the area where you write the code on the text editor and the compiler gets that C file and it converts and gives you an assembler source code. And the assembler gets that assembler source code and then it converts to give you a object-oriented files. So then the object-oriented files is sent to the linker. The linker gets the object-oriented files, or the object files I should say, and then it gives to the linked object files, otherwise ELF format, and that's where it's feeding to the loader. The loader gets the ELF file and gives the last list of files, and this is the one which can be downloaded to the external memory as the hex file format. So likewise, all these four combine to do the task of programming and compiling, making it possible for us to happen so that you can fire into the target board. So that is what these four major players does in IDE. And next one down is the editor window, console window, and project window. So you will see when you get into the IDE there are different windows. So the editor window is where you will write the code, the C code. The console window is where you will see the outputs of your written code. And the project window will be the ones you going to manage about files. There will be multiple files, and that's where the file management comes in, and you will do that in the project window. And there is an option to debug and release. So this particular IDE can do up to 20 options are available to do both debug and release. So what is a debug? When you compile the C code, you compile the program, you build the project, and in the debug mode, it gives you the debug information. It generates you the debug information, and that is necessary to debug the program. In case if you missed out on anything, any logic is missed out, any functionality check, if you accidentally typed the wrong word and there is a link missing, those sort of things can be analyzed in the debug, and you can fix it to be more completely bug free. So once that's done, then there is another mode called release mode. In this mode, when it is bug free completely, then it is released for production. So the production people gets this once all the error free code from the debug stage move to the release, where they get it as in a hex format, and they will still further reduce the size and make it even error free in the release option according to the production checklist. Then there is a memory window. The memory window is in this one. In this window, you see the values of both the flash memory and the SRAM memory, the data memory. The flash memory is where your main program going to sit for the boot up options, and SRAM is where all the data memory is going to stay there. And then the register window. The register window is the one where you can see all the registers that's used in your coding, and you can dig deep in and click on each and every register, and you can see the value of that registers, how it's linked, and what is the hex value of a particular register, etc. So that's really interesting when you come to the IDE and do your program. And also there is two good points in the IDE. You can set your breakpoints, meaning you can stop your program from execution, and at that point you can check the value of the register from where it's coming and how it's going. So that is a breakpoint where you can ask the compiler to stop and set a checkpoint, if you like. That's called in technical term as a breakpoint, to check the value of the variable. What is a watch point? So when you stop at the program at that point to verify a condition, you write certain conditions and to check certain conditions are met or not. So to verify that, you set a watch point. So that is a watch point to check whether that condition is met or not. Example, if a variable, if you written a variable and pass it to the variable, at that watch point you're checking whether that variable is written to that variable or not. So that is the purpose of the watch point. Debugger is a button or a tool that connects the emulator with the hardware, so that gives you options to debug to make your code bug free. In real-time analysis, you connect the IDE to the target board via the debugger option, so that's why you can analyze. And you can do debugging analysis on in terms of two perspectives. One, C++ development perspective, and the other one is in terms of further development, what it's all going to give you. So that is the IDE. The debugger perspective is once the download program to the hardware and starts to debug, that's the debug perspective. That's what it will do. Once program downloaded, after that you do certain steps, and that's the debugger does. And programming options. Some IDEs will have additional programs, options to programming microcontrollers, some won't, so it depends on what IDE it's used. For example, on a 8051 IDE, if you use NXP semiconductors, need an additional flash programmer to load the boot program, whereas this IDE has a built-in functionality, so you don't have an external programmer to program the bootloader. So things like that. If you have a Nuvoton ISP programmer, it has in-circuit serial programmer. So always check with your software reference manual. Sometimes IDEs need the special connector or a special programmer. So please check with the IDE before choosing into your software needs when you sit for that software selection part of it. Now let's go through the software development flow. As you have realized or remembered from the previous sessions, the software flow is where you write a C program code, and the C program code fetches and compiles and generates an assembler source code. The assembler source code from the achiever of the macro library generates the object files. The object file sends to the linker, and the linker is the one which generates the hex file format, and the hex file is downloaded directly to the target hardware through an emulator. So that's the software design flow, and if you go through this flow chart, you will know what exactly the development flow method is. And this is about multi-flow when you try to this is more to emphasize on the linker, how it prioritizes and how it gets the C code from various options of C, and how it can move from location to an executable file. So this is about the software development flow. I talked about linker briefly, I think on day 2. So this is where the linker I'm going to give you more explanation about. So when you work on a major project, like a complex project, the default linker will be by default connected to the external memory, just to avoid congestion on the main microcontroller memory. So it will be added to the external memory to do multiple complex things. So imagine if your processor is only 512 kilobytes of memory in there, and if you, for example, want to process a video process, and it has to do its mathematical calculations to calculate 256 times 256, which will be about 65,000 pixels it need. So your microcontroller may not be able to do that, so that's why you need an external memory where you link this microcontroller memory to the external memory, and to do that you need a linker. So actually in the industry there is actually a dedicated engineer who does only but write linker codes, and on this one itself, it's a really good interesting thing, because this is the one you're making the initial code to work on a larger version, if you like. So the linker is really important, where it does all its mathematical calculations, its coefficients, and anything in between in the intermediate values where you can keep internal or external. And when the memory allocation starts changing, that's where you need the stack, where all the memory is listed, and it has the starting memory line to the ending memory line, and it's all stacked up. So just to give you an example here, in this section, every C file we have C sections. So every C program consists of different parts in your code. It's classified as a section. So all default section name begins with a dot. For example, short m, that's a .bss section. The variable that's assigned, the value that's assigned to that variable m, it has a dot extension .c in it. And likewise, when you start with the main op, so short y of 0, this is where the memory starts to happen, the stack. So anything that's declared inside main, it's a local variable. Anything which is declared outside, it is a global variable. So you can use it anywhere in the program. And then there is a set of instructions. There is a multiplication, and there is an addition. So that's where the real code sits, and that's classified as a .text extension. And then you verify the results by a printf statement, and that is standard CIO .CIO. So this will be the standard in most of the IDEs. So the linker description file is really important. Let's see how the linker description file in the memory, how it's all located. So in the external memory, when we are talking about the microcontroller will have its own internal memory, and that's linked via the linker to the external memory. This can be the DDR2, flash, whatever the case may be. It will have a starting address and an ending address, starting address and ending address. So whenever you assign some data to variables, this is all the sections where it will go and be located at. So the dot text that you see from the previous slide, it sits on flash location. The dot C in it, the global variables, that will stay in the flash location. So these two must be staying outside, so they must exist after every reset. Whenever you do reset, these two will be ready to go and boot up and run. The others .bs is the global variables, and the internal variable that's inside the void main, it will all sit in the internal memory that should be in the RAM memory. So this is just to give you an idea about how and where your data move from after you compile and generate that code, and this is where the sections sit in the actual memory mapping. Then we talk about the compiler section names. So as we already know about few section names, .text is a code, .switch, .constant, .init is a global or static variables, .pin. So these all memory types that has to be initialized. So there are also uninitialized memory types. For instance, the global static variable .bss, .stack, the local variables doesn't have to be initialized. You can directly assign to it. So that's what uninitialized means. Whereas these outside ones, you have to initialize first and then assign values. So this is about the compiler section names. Now let's see briefly about a structure of a linker file. So this is how the linker file starts with. It all sits with a linker.command cmd file, which tells you the different hardware memory locations, its length, its location, where it's going to sit, and also it will declare its software sections. So name of the memory, whether it's internal memory or an external memory, etc. So you will have both the hardware memory description and the software sections in the linker.command file. And once that's all done and linked, that's sent to the linker. So you receive the object files from the assembler, which generates and send you the object files. So the linker gets the command files and the object files, and it gives out as a .out to send to the loader, where the loader sends the hex file format to the target board, and also the linker maps through .map for the external memory allocations. So now we're going to see a sample of a linker command file. So if you work in bigger companies or bigger teams, the when you check with the software reference manual, so it comes with a command file. So this is how it's categorized. It will always have the .lib as a library, so it has to fetch anything from the library, and it will have stack and heap sizes. So what is the size of your stack memory and what is heap, and also the memory areas, as I was saying earlier. So it has to have a length and origin of where it's going to sit and where it's going to finish. So likewise, you have to categorize all the memory areas and the sections where you have the code and the data section. So .bss sits in the IRAM, .text sits in the DDRM, .cinit sits on the flash. So this is a sample command file. This is how it looks like. Again, in the industry, there is more specific specialist will do all this command file. Once you are familiar with the first 2 years, then you could move into writing a linker file and a command file program, which is more in-depth programming. So what are all the IDE and the compiler used in this course? So we have a target and a host, as we call in every programming, every IDE. So the target here we're going to use is the STM32Cube IDE, and the processor, the board that we're going to use is the STM32F411RE, and the host is where the IDE lives, where it sits. So the host for the IDE to run and produce and generate the output, you need the GCC compiler for desktop and laptop. So these two are the ones you need to get your IDE installed and get going. And there is a concept called cross compiler. So what is actually a cross compiler? The PC generates, the PC generates iCode, a machine code on ARM code. When compiling for host, you can't simply transfer that to the ARM architecture. So for example, if your PC generates a code, it has to send to a target architecture via a programmer or IDE link. So that's what it's called as a cross compilation. So you're doing a compilation in one environment and moving to the target environment. So that is where the cross compilation process hits. And it always, when you download to the target architecture, it always goes in .hex format or .bin or .elf. But mainly it's .hex. So this is the cross compiler. There is two technical terminology that you have to understand about when you do the host machine compilation to the embedded processor, the target compilation. For the target compilation to run in the host machine, you need a GCC. GCC, it's a compiler tool. GCC stands for the GNU Compiler Collection, which is commonly known as GCC. It's a set of a compiler and a development tools available for Linux. It's not Unix, it's available for Linux, so that's what it's GCC stands for, and it's Windows based, and a wide assortment of other operating systems can also be used. And what is a MinGW? The MinGW is a minimalist of GNU. For Windows. For Windows, you need a special file to run and the compilation process to happen. So formerly it was named as MinGW32, and now they're coined as MinGW. So it is a free and open source software development environment to create Windows applications, and you can run your code into it. So this is the two files that you have to remember the name, and these both could be interview questions. So they could ask you what is a GCC and what is a MinGW, and you would be able to answer it by now. So again, the GCC stands for GNU not Unix. So it's an abbreviation from GNU. It's not an Unix, but it's an Linux. So that's what it says. This is the IDE download link that I shared with you. So please click on that link and then start to download that. It will take at least about 5 minutes, depends on your internet process speed. The size is 2.7 gigs, so please allow yourself, your computer, to have that 2.7 GB, and click on this tool and start to download. And I would like to give you a bit of a break, so please do that on the background, download this, and we'll catch up in 5 minutes time, and I'll go through with you the setup of IDE. Thank you. I'll see you again in 5 minutes. back. I hope you enjoyed that bit of a break and you were able to stretch and relax a bit and get your energy flowing back. So yeah, let's get back to it. Um, as I said, please use this link to download the Cube IDE. After you hit that link, you have to scroll all the way down and it says where get software, and if you are using a Windows PC, then you have to get the Windows installer, so STM32Cube IDE, and you have to click on get latest, and this will start to download the files. So once it's downloaded, these are all the steps you have to follow. It's pretty much easy, but not to scare you, I just given you almost every screen that you will face when you start to download and up to when you finish the installation. So it's all pretty much follow on the instructions on the screen. So just follow the screen instructions, and you can keep this as your reference, and you can just follow step by step. So from it starts from hitting the get latest, and it will download a .exe file. You have to double click on that. It will always be downloaded as a zip format, so you need a special software called WinRAR or WinZip, where you can extract all the files and start to do your installation. You have to say yes, and then pretty much from here just say next, and then I agree to the license agreement, and then it will ask where the destination folder have to sit. You just click on next. By default you will get the destination folder located to C drive, and then once it starts, it will start to extract files, and then it will ask you to tick on both drivers. That's essential, so please tick both the drivers and then click install. It will start to install, and then once it's all happy and joyful, it will give you a message as installation complete, and the final screen will look like this: STM Microelectronics Cube IDE, and it will give you information that it has been installed on your computer. But please remember to tick this desktop shortcut. It is easy when you do it here, otherwise you need to go into the IDE and you need to do the options. That's a bit complicated for a starter, for a beginner like you, but yeah, please remember that to click on create desktop. I also did a short video on how to install from step 1 to the final bit. I'm posting that after this, so you can also keep that as your reference and follow that. So once you downloaded the IDE is where you write the code and compile without errors. And then for that code to run without any problems within your host machine, that is your PC, you got to install mysys2.org. So you have to hit on this installation link, and then you have to look for mysys2. It's all by default, and then browse, and again you have to follow the steps just I marked like this. So once it's downloaded, then please enable the run button, and then start to install, and then it will start to run, and then the end message will also say completing the MC64 bit, and then you can run it from here by clicking on that button. So after step 2, on a command prompt window, please type in msys2, and you would see something like this, msys2, and the prompt will be ready to receive your next command. So on the after you type the msys2, this is the shell script that you'll get. It takes roughly about 20 seconds to get the shell script, and this is where you're going to update the system packages in order to get normal transition without any error. You have to do all these initial setups. This is also part of the architecture extensions where you have to set up all of this. So in this is where you're going to do a system update. So update the package, database, and base packages. Sometimes the setup file will come automatically in its own zip folder. If not, it will take at least 2 steps. So don't worry, I also did another short video to show you exactly what to do, so follow that. also follow the screen prompts that with these slides. So all you have to do is the dollar comes and blinks automatically. All you have to type is pacman space dash SYU, capital SYU, that is pacman, that is packet manager short form, that's a term, PAC man minus system update. So after you hit enter, this is what happens. It starts to progress by fetching all the necessary files, and you'll see the warning, please ignore all the warning, it's just doing its job. And it will ask now and again, would you like to start, would you like to proceed? So always hit yes and press enter, and once it's done, you will get a message saying you it is ready to install. So at this time you have to do another toolchain link. So this is to connect your GCC compiler with the system package. So this is the command. So pacman minus s needed. So the whole thing copy and paste and hit run. And you get into this screen where it throws you about options with which MinGW you have to install. So we are targeting to install MinGW 64 because it's a 64-bit processor, so that's why we targeting number 3. So after 3, if you hit enter, then it does all sorts of checks. It has to load all the 28 sections of the files, and once it's all downloaded and installed, and you will get with your desktop number and sits with the prompt. So that means it's all installed and ready to go. And then once you install the IDE and the system updates, then you have to set the environment to make your variables work and link with the program. So these are all the steps you have to follow. Again, it's simple and easy. Just follow the prompt, follow the screen instructions. So on the search, just type in environmental variables and hit enter. You will get this window. On this window, click on path and then click on new. When you come to new, you have to basically link both the EMSys64 and MinGW64 bin. So follow the sequence of left and then the right, then the right, then down, then left, then down, then left, then down, then left. So if you just follow this order, then you would simultaneously end up like this, adding 2 files. And once you're done added successfully with the MSys64 and MinGW bin, then there is a OK button which is hiding there. I couldn't put that into the screen, but yeah, click that OK button, and the environment variables is all set. So that's all you have to do. IDE, sys 30 sys files, system update files, and the environment variables. These 3 are the necessary files that your computer need to have for your code to work. Otherwise you can't compile and see the output of the code, whatever you're writing on the editor window. So just to test the compiler whether you got all the MinGW files are installed correctly, so again you go into the command prompt and type in GCC, and you'll get a fatal error, ignore that. And after that you type in where GCC, and you'll get this path. If that path comes you with the .exe, that means yay, you have done your job, it's installed correctly. If not, don't panic, please go back 3 slides and start with IDE installation, then the system update package, then the environment variables. You will eventually end up in here. Also, for your reference, I'm going to include those 2 videos. Please do also follow that videos, and you will be able to do it all by yourself. So you are ready now. You got everything covered and all the tools necessary for writing your own program, and this is how you're going to generate or create a simple project in your IDE. So connect the target board. So this is the target board, and that's the USB pin. So with this pin, it comes with a cable, so you need to connect that to your USB port of the PC. So that's the illustration. So this board is a Nucleo F411 board, and it connects via this SWO pin through the ST link, the debugger and the programmer, and connects to the PC. I'll show you how when the next time when we do the real-time debug. I'm going to show you how, but this is how it's connected to interface with the IDE. So that's the target where you're going to focus on. That's the USB connector, and that's where it's connected. Okay, let's talk about serial wire debug. The serial wire debug is the way to program your target board. So ARM introduced this from JTAG. JTAG is a Joint Test Association group, which can be done with 4 pins. In order to reduce the number of pins, they introduced this, and all you need to do is you need to have only 2 lines. It operates on the bidirectional data line and a clock line, and through this 2-wire transform you can actually program, send or load the program to the target board. And it happens on the ITM unit. The ITM is an optional application-driven drive. It supports printf style debugging when you want to see the printf and actually want to see the output in the console window. This is where it comes in handy, and this is sitting inside the your processor. So serial wire debug, SWD, is a 2-wire protocol for accessing the ARM debug interface. In case if something you got bugs or anything, you also have to use this serial wire debug, and it will help you to debug. So as I said earlier, so the SWD stands for serial wire debug. It's a 2-wire protocol to access the ARM debug interface. It's an alternative to JTAG, Joint Test Access Group, and SWD is a part of debug specification version 5. It has 2 physical layers and it has 2 lines. SWDIO, it's a bidirectional data line, and a SW clock. With these serial wire data debug interface, you should be able to program micro memory control unit internals flash to access to the memory regions, to add breakpoints, and you would be also able to stop and visualize what's happening in the breakpoints, and also you can run the CPU as well. So the other advantage of using the SWD is you can do debug options with printf, meaning with console outputs. If you want to see your output in the console rather than on the target board, on the actual board, you can see it on the console window. So that's where the SW is really handy to have. So thank you for ARM for introducing such a easy tool. So it is very easy and cool when you get to programming. It's all very, very exciting. So I'm sorry to bore you with all the theory so far, but these are all the essentials you need to know. This will also help with your interview questions. You will feel more confident because you are learning the theoretical part and how you're going to link that to your hands-on. So this is all necessary you have to learn. So how the transition happens from JTAG to SWD. So the JTAG was used as a traditional mechanism to debug. It started in ARM 7 and 9 families, and then when the Cortex-M family was released by ARM, they also introduced this SWD to make it to make life easier for the software design engineers. So they also reduced from 4 pins to 2 pins. So with the 2 pins, you would be able to program that. And also, it has the additional serial wire output pin, which is used for a serial view wire wire viewer, which is a low-cost tracing technology. You can actually view the data points where it's all connected. So this is how the connector looks like, and that's the JTAG pin description, and this is the SWD pin description. So it can run on low voltage, 3.3 volts with 2 lines, software clock and serial wire clock and serial wire data. So these 2 are the pins, and the serial wire is to locate to view. Now let's discuss about the debugging options on embedded core. But before that, I'll give you 5 minutes break, and I'll catch you soon after the break, and we'll go through all of this. There is few little things to cover, so I'll catch you in a while. Thank you. Hello and welcome back. I hope you all enjoyed that long break to make it to stretch your arms and legs and get the energy flow going. Let's cover up the rest of the A4 concept. So we're going to see about the debugging options on embedded code. First off, we're going to see the serial wire viewer. Yeah, through that pin connector, through one of the pins, you get serial wire output. So you can use that pin to see the serial wire viewer. You can debug. And the next one is the single stepping over and stepping out. Single stepping is when you do the debug, you can debug line by line. So to stop the program exactly at that point of line, and you can debug and see what that piece of code is up to. And the stepping over is what we call as having a function call. So if it has to go to a different section, it skips over that section, and then from there on it runs in a single step. So that is what it's stepping over is. And stepping out is come out of the total function loop. So this IDE supports that stepping over and stepping out. Breakpoints we already discussed earlier. It's to halt the program at one single point in the code, and you can debug that point to see what's happening with the code. The next one of the rank is disassembly. Disassembly is a assembly program which you can see the conversion of C to assembly. The same code that you written in C language, through this option you can change that to assembly language. And the next one of the list is call stack. This option will show how the function is called in the code, in the written code, and how its hierarchy are leveled from top down hierarchy. It shows the overall flow of the program, how it starts and how it ends. And then the next one is the expression and variable windows, where you can see the real-time mathematical calculations of the expressions, and you can see the result in the variable windows. And we have the memory browser, and we have data fetch points, and the SFR windows. It's the special function register windows, where you can click on this and you would be able to learn about each and every individual special function registers. And there are some other basic features. When you prod along with all the other buttons, you will know about the other options. So these are all the basic debugging options that's available on this particular IDE. So let's get to know a bit more about the STM32Cube IDE. It has the following pages. When you go into, when you launch the IDE, what you get to see is the importer and the IOC editor. The importer is where you can create your new project, and you can save all your project work into that particular tab. And then there is the IOC editor, where you can see the actual chip. As you can see, the IOC gives everything all about the chip, the pin description and all the details of the chip. Then the section is the code editor, where you put your code in there, and then you can use your symbols to highlight it with the use of hyperlink. And also it has a inbuilt include browser. From there you can click on the various hierarchies that you can see, and also the call hierarchy, where whenever there is a function call, it will show you where that is going to go. And then there is a brace navigation, where the braces are connected. So if you click on suppose you are on say for example you are on the 500th line of your code, and you don't know where the brace starts or where it's going to finish. So if you just click on one end of the brace, it actually takes you to the top end of the brace, and you know the whole function list that you created. So these are all really handy tools that comes with the IDE that helps your job really easy to write your code. The next one is the debug and program. So you have the OpenOCD GDB server options where you can connect to your programmer and use the options for debug and program. As you know, SWD can be used with the debug and also the program. So you can check on your program on the external memory, how it is all stacked up. It has got a multi-core debug, and also this IDE supports the trace support, so you can actually see the clock and how fast a process is happening through the serial wire viewer. And in comparison, when you compare with the other Cortex series, Cortex M4 has both the debug options with JTAG and SWD, but in this course you're going to learn about the SWD debug. And also it has the trace port in the serial wire viewer where you can actually trace all your coding levels, which you don't have that in the M1 M0 Plus. The rest all other process have this series has it, M33 and M7. So this, when you click on the serial wire viewer, this is what you see. You see the real-time trace that uses the SWD port and the SW0 pin, and also the advanced debugging option without halting the MCU. And without halting your main compilation, you can click on this and you'll get a different plots about the inputs and outputs and what's happening between the registers. So you get the plots and the logs. And there are more options to explore with this SWV. You can use this icon to trace on the live data trace, and you can watch it live. Actually, the graph changes, and with this icon you can use the data trace to timeline the graph, and with this icon you can see the printf output console redirection, and you can measure the timing measurement. You can do with this, you can see the exception log and timeline graph, and also you can see with this shows a statistical profiling of whatever you clicked on. It shows whatever you clicked on previously, so it gives the whole statistics. And it also comes with a build analyzer just to check your code size, and also the static stack, which shows you the function size. These are all built-in IDE functions in there that ST is really proud of. ST Microelectronics does this, so that's why it's one of the really popular tool for any designers to use. And also there is another option called binary change, where you can convert your hex values to binary and binary to hex. So just to see if you want to see in different values, if it makes it easier to explain to other people, so this binary change will come in handy. And it sits in project under properties, and C++ build. If you go to settings, you can just go to tool settings, and there is a MCU post build option, so you can click that to change to binary or hex. This is what the SWV data trace will look like, the serial wire. So it depends on whatever the code you have written. You just click on the SWV, and this is the live graph that you will see. So what are all the debug features this IDE has? As we discussed in depth, it has the serial wire debug, which is similar to the JTAG but with fewer pins. And with serial wire viewer, you can actually view the real-time tracing, the real graph that happens. So you don't have to stop the compiling. When you click on this, you will see the continuous happening of the input and the output. And to sum up, the advanced features are the statistical profiling, the memory access logs, the live variable view, and the data tracing, the event notification. If something the IDE wants you to do, it will notify you. And also the software trace. If you got different versions of your software, this has a feature to let you know what the previous versions are. So these are all really handy features to have. And some of the programming techniques that are widely used in the industry and also with some of the IDEs is the In serial programming, where you can do programming on the spot, and there is in circuit serial programming, where you can program when you connect with the target board. And there is the important thing, what is called the IAP, which is you can do an in-application programming, meaning over the air. Say, for example, the customer or the client has your product, and if you want to update a software or a firmware to that particular device or particular component or module, you can do that by this option, IAP, over the air. So you can talk to it by their addresses. The next one is the JTAG that we know. It's a joint test access group. It uses four lines to do the programming technique, and also the serial wire debug that we learned already, that it only needs 2 wires and you can program it. That so it's simple, and it's a new introduction with Cortex-M series. So just to rewind of what we learned today. Today we learned about IDE, what is it, and how it works, and you learned about linker, why is it so important in the project, and how you can write your own linker script, and also much detailed steps about installation of the STM-Cube-IDE, and about what are all the options it has inside the STM-Cube-IDE, and also the debug options for embedded code out there, available out there, and how to do the program for your target board with all those ISP, IAP, SWD, JTAG, etc. And let's get into the mindset activity for today. It's focused on discipline. So imagine you are in a monastery, or if you are in a Buddhist temple, and if you closely observe all the monks or even the Hindu priests, before getting into the priesthood, they have to follow a lot of rules and lot of procedures, so they get themselves really comfortable in doing what they got to do, and also that changes them morally and physically. It makes them as a new human to change. So these are all the activities that you have to keep following every day. Do exercise every day at the same time, if not different time, but do exercise. That makes your mind and the body relaxed, and also you need that break from away from the screen, so you need that exercise. And always please try to eat healthy food, don't go for any junk food, because you have to look after your health as well. Health comes first. So if you feel sick, your mind can't think straight, and you will make a lot of mistakes in designing things. So that's why the healthy food comes in handy. And also the third thing is to meditate. Please meditate at least 5 minutes or 10 minutes to take the stress away from or the worries away from your mind. Just empty your mind for a while and then come back to it, and you will get plenty of new ideas. And the next one is organization. Organization, I'm talking about your own organization, like how to keep your working desk tidy, or your room tidy, so that everything is neat and put to its place. It's a matter of practice. So when you start to do things, your subconscious mind actually sets you to feel better, feel more energized when you walk into some room. And also time management is really key. When you set on some targets, please follow through and set yourself some time so you finish that particular task in that time frame. So the time management, it's really important when you hit the industry. Even if you do your tasks or not, but if your senior engineers or your managers ask you to be there, say 9 a.m. in the morning, you have to be there 10 minutes early at least. That's how you create the relationship between the workplace managers and the senior engineers, and also that promotes you in the company, and also that promotes yourself, your inner self, that you can be well established and start your work on time. And also definitely set your goals every day. Don't forget to do any goal settings, because that gives you something to look forward to do it. Keep going and until you accomplish. So please do the set goals. And also please learn to show your gratitude no matter what it is. Please thank your close, near and loved ones, because they do a lot of things for you to do this study. They do sacrifice. They do a lot of things, especially our parents. They give this money to you to so that you can purchase this course and learn. And also your mom makes drinks and meals so that you won't miss the class, or you come to do it effectively. So please show your gratitude to others in helping whatever way you can. So that is really important. And the main thing is please have at least 6 to 8 hours of sleep, and that re-energizes you for the next day so you can keep going. But please don't put that off for any reason. I know the mobile phone and the TV programs are a big distraction these days. There's plenty out there for entertainment, so forth, but please keep that in mind and have at least 6 to 8 hours. That really helps, and I personally experienced that throughout my career. So on days when I have less sleep, I'm not as productive as I would like to be at the workplace. But when I had the 8 hours sleep, I was really sharp in all my tasks. I was able to get come up with brilliant ideas, and I can fasten up my tasks. So sleep is really important. And also why I put love and pain together is you have to feel something, and then you have to realize and understand. So you have to feel for something, and then you'll get that in the form of rewards of love, so be it from your close loved ones. And also the relentless persistence. Keep that going attitude. Keep on going. Don't stop at any stage, because every day is a learning curve for you. So we get to learn every new thing every day, even if it is a small thing. It's good that, but don't lose your persistence. So these are all the mindset activity that I would like you to follow from now on, and that will eventually make you to change and be a more active person. And the usual mindset involvement. So if you do all of that, please do follow all of that, and please post your achievements in the Facebook group so everyone see what you're up to, and that will give a lot of encouragement to other people, and it will motivate them, and they can follow, and we have to help each other out. And also, if you have any questions about these course contents that you face, then please post that in the group. Also, it's not that, and also the combo with the internship, it's coming your way, so please stay tuned for that. It is the embedded C programming with the current series of Cortex M4, and then there is furthermore bundle courses that's coming. You'll get all of that, and you'll get plenty of notice and plenty of announcements when we launch that. But please stay tuned, and I would highly recommend you to join the internship, because you get a lot of benefits from internship. You get all the course materials, you got the PPTs, you got all the videos, so you can go back to and watch many times as much as you like, because you get the lifetime validity. So that shapes your future goals, so you can have that. Whereas the other YouTube viewers, they won't get it. They will just have to attend the YouTube session and just watch it and take notes. So that's why I strongly recommend you to join the internship, and I'm sure you will get a lot of value from that. And I thank you sincerely for all your patience, for all this time to learn day 4 tasks, and please go and get that deserved break from the screen, and This is Arulan Bukarasu. I'm signing off on behalf of A2DG. Until I see you in the next lecture, which is day 5, it will be hooroo from me. I'll see you in the next session. Until then, take care and have a lovely and fruitful day. Thank you.